Hello friends, welcome to all of you in this ninth standard mathematics part first. The topic is ratio and proportion part 5. Friends, in the previous session of this ratio and proportion part 4, we have been discussed with theorems on equal ratios and problems from the practice set 4.4. Today we will discuss with the following subtopics: continued proportion, K method and problems from the practice set 4.5. So let's start with the continued proportions. Friends, we will now see what we mean by this continued proportion. Three quantities are said to be in continued proportion if the ratio of the first term and the second term be equal to the ratio of the second term and the third term. So continued proportion, let the three numbers be a, b and c are said to be continued proportion if a, b and c are in proportion. So thus if a, b and c are in continued proportion, then a, b, b, c are in proportion. That means a has to b is equal to b has to c. So product of extremes is equal to product of means. If AC is equal to b square, then dividing both sides by bc, we get a upon b is equal to b upon c. If AC is equal to, therefore we can write that AC is equal to b square, then a, b, c are in continued proportion. When a, b, c are in continued proportion, then b is known as geometric mean of a and c, or mean proportional of this a and c. Now, hence all the following statements convey the same meaning, that a upon b is equal to b upon c, or b square is equal to ac. A, b, c are in continued proportion. B is the geometric mean of a and c. B is the mean proportional of a and c. So we can generalize the concept of this continued proportion as if a upon b is equal to b upon c is equal to c upon d is equal to d upon e is equal to e upon f. Then we can say that a, b, c, d, e and f are said to be in continued proportion. So friends, I think you came to know continued proportion. Now we'll see the K method. The K method is used to solve the examples based on the equal ratios, that is equal proportions. In this method, we equate each of the ratio to a number k and then solve the problem. Hence, this method is called as K method. If a, b, c, d are in proportion, then a upon b is equal to c upon d. Let a upon b is equal to c upon d is equal to k. Then we can write that a is equal to bk and c is equal to bk. This is the case with proportion. If a, b, c are in continued proportion, then we can write that a upon b is equal to b upon c. Let here a upon b is equal to b upon c is equal to k. Then we can write b is equal to ck and a is equal to bk. But the value of b is ck, we'll put here. So ck into k is ck square. So a will be ck square in the case of continued proportion. Friends, now we'll see that practice set 4.5. Problem number 1. Which number should be subtracted from 12, 16 and 21 so that the resultant number are in continued proportion? Friends, let the number to be subtracted be x. Then we can write 12 minus x, 16 minus x and 21 minus x are in continued proportion. So we can write from these 12 minus x upon 16 minus x is equal to 16 minus x upon 21 minus x. Therefore, we can write that 12 minus x minus of 16 minus x divided by 16 minus x is equal to 16 minus x minus of 21 minus x upon 21 minus x. Means for this step we are using a dividend. We'll solve the bracket, we'll get 12 minus x minus 16 plus x divided by 16 minus x. So 12 minus x minus 21 plus x upon 21 minus x. So at the numerator my x get cancels on both sides. So we'll get minus 4 upon 16 minus x is equal to minus 5 upon 21 minus x. Therefore, on both sides we can cancel the sign negative. So we'll be getting 4 upon 16 minus x is equal to 5 upon 21 minus x. So cross multiply. 4 into bracket 21 minus x is equal to 5 into bracket 16 minus x. Therefore, we can write 84 minus 4x is equal to 80 minus 5x. So friends, now here will 5x minus 4x will be equal to 80 minus 84. So x is equal to minus 4. So minus 4 should be subtracted from 12, 16 and 21 so that the resultant number is continued proportion. Next, number 2. If 28 minus x is the mean proportion of 23 minus x and 19 minus x, then find the value of x. Friends, 28 minus x is the mean proportion of 23 minus x and 19 minus x. So it is given. So we can write that 23 minus x divided by 28 minus x is equal to 28 minus x upon 19 minus x. Therefore 23 minus x in one bracket minus of 28 minus x divided by 28 minus x is equal to 28 minus x minus of 19 minus x upon 19 minus x by using dividendo. So what will happen? We'll solve the bracket. 23 minus x minus 20 plus x, 28 minus x is equal to 28 minus x minus 19 plus x upon 19 minus x. So from the numerator x get cancelled, so we'll be getting minus 5. Difference between 23 and minus 28. Minus 5 upon 28 minus x is equal to, on the right hand side, 9 divided by 19 minus x. We'll cross multiply. Therefore minus 5 into bracket 19 minus x is equal to 9 into bracket 28 minus x. So solve the bracket, multiply. 5, 19, product is minus 95 plus 5x is equal to 252 minus 9x. So friends, 5x plus 9x is equal to 252 plus 95. So 14x is equal to 347, therefore x is equal to 347 upon 14. There is no division possible, so the value of x is 347 upon 14. Now problem number 3. Three numbers are in continued proportion whose mean proportional is 12 and the sum of the remaining two numbers is 26. Then find these numbers. Friends, here let the first number be x, then third number is 26 minus x, because they have given the sum of the remaining two numbers is 26, means here we'll get the third number as a 26 minus x. 12 is the mean proportion of this x and 26 minus x. Therefore x upon 12 is equal to 12 upon 26 minus x. We will now cross multiply. X into 26 minus x is equal to 12 into 12. So 26x minus x square is equal to 144. So we can convert this into a standard form of quadratic equation. X square minus 26x plus 144 is equal to 0. This 144 is split in such a way that the product is 144 and sum is minus 26. So it will be x square minus 18x minus 8x plus 144 is equal to 0. Among these first two terms, x square minus 18x, x is out. Into bracket we can write x minus 18. For the third and the fourth term, minus 8 is taken common. So in the bracket it will be x minus 18. Among these x minus 8 common taken out, in the another bracket there will be x minus 8 is equal to 0. As the product of the two terms is 0, means here x minus 8 is equal to 0 or x minus 18 is equal to 0. Therefore we will get x is equal to 18 or x is equal to 8. Third number is 26 minus x, means 26 minus 18, that is 8, or 26 minus x is equal to 26 minus 8 is equal to 18. So the numbers are 18, 12, 8 or 8, 12, 18. Now we'll see problem number 4. If a minus b plus c, another bracket a minus c plus c, is equal to a square plus b square plus c square, show that a, b, c are in continued proportion. Friends, here in the one bracket a plus b plus c, another bracket a minus b plus c is equal to a square plus b square plus c square, it is given. So we can write here that a into bracket a minus b plus c, each term of the first bracket should be multiplied with the complete second bracket. So into bracket a minus b plus c plus b, a minus b plus c plus c, a minus b plus c is equal to a square plus b square plus c square. After solving this bracket, you are getting a square minus ab plus ac plus ab minus b square plus bc plus ac minus bc plus c square is equal to a square plus b square plus c square. Friends, here a square minus ab and here is plus ab get cancels. This plus ac plus c, it will be 2ac. This minus b square plus c square is equal to a square plus b square plus c square. From the both sides, a square and c square will get cancelled. So we will be getting 2ac minus b square is equal to b square. B square, but to the right side it will be plus. So 2ac is equal to 2b square. So b square is equal to ac. We are getting b square is equal to ac. Therefore a, b, c are in continued proportion. Now we'll see problem number 5. If a upon b is equal to b upon c and a, b, c is greater than 0, then show that a plus b plus c in one bracket, a b minus c another bracket is equal to a b minus c square. A square plus b square in one bracket, b square plus c square another bracket is equal to ab plus bc bracket to square. Or third one, a square plus b square upon ab is equal to a plus c upon b. We'll see first one. Let a upon b is equal to b upon c is equal to k. So therefore we can write b is equal to ck and a is equal to bk, that is ck into k, that is a is equal to ck square. We'll take the first example. A plus b plus c another bracket b minus c is equal to ab minus c square. We have proved that b is equal to ck and a is equal to ck square. We'll use this. So LHS is equal to, we'll get a plus b plus c one bracket b minus c is equal to, put the values, a is equal to 6 square plus ck plus c, ck minus c. Here c is out, k square plus k plus 1, c into k minus 1, c square, k square plus k plus 1 another bracket k minus 1. This is let equation third. Now RHS is equal to AB minus C square, which is equal to, put the values, k square ck minus c square. So c square is out, k square minus c square. So RHS is equal to c square k cube minus 1. So here it could be a cube minus b cube formula we can use. That is a minus b, a square plus ab plus b square. Accordingly, you can write c square k minus 1, another bracket, k square plus k plus 1, equation 4. 3 and 4, both the equations are the same. So from 3 and 4, we can write LHS is equal to RHS. Therefore, we can write that a plus b plus c in one bracket, b minus c, another bracket is equal to ab minus c square. Now try for the second example. That is a square plus b square plus c square is equal to ab plus bc bracket square. But we know that b is equal to sec and a is equal to sec square. So LHS a square plus b square, another bracket is b square plus c square. We'll put the values. Ck square bracket is to square plus ck bracket is to square is equal to ck bracket is to square plus c square from 1 and 3. Substituting the values. So c square k fourth plus c square k square plus c square. So now c square k square is common, taken out. In the bracket is k square plus 1 and c square k square plus 1, c square k square, that is c fourth k square plus 1 bracket is to square, equation 3. Now RHS is ab plus bc bracket is to square, ck square into ck plus ck into c bracket is to square from 1 and 3, substituting the values. So here we will be getting c square k cube plus c square k bracket is to square, which will be c fourth k into k square plus 1 bracket is to square. So c fourth k square into k square plus 1 bracket is to square, we can write fourth. So from 3 and 4th, we can write that LHS is equal to RHS. So a square plus b square, one bracket, and bracket b square plus c square is equal to ab plus bc bracket is to square. This is third. A square plus b square upon ab is equal to a plus c upon b. Friends, we know that b is equal to sec and a is equal to sec square. So LHS, that is a square plus b square upon ab. Put the values. A is equal to sec square brackets to square plus b sec square. At the denominator, sec square into sec. So here will be c square k fourth plus c square k square. So here denominator c square k raised to 3. So c square k square plus 1 c square k raised to 3. So you'll get, after cancelling the terms, you are getting k square plus 1 divided by k. Equation 3. Now RHS a plus c upon b is equal to, put the value ck square plus c upon ck. C is common out, k square plus 1 upon ck, cc get cancels, and we will be getting, that is k cube plus 1 upon k. Equation 4. From 3 and 4, we can write LHS is equal to RHS. So a square plus b square upon ab is equal to a plus c upon b. So this is what the third problem. Now problem number 6. Find mean proportional of x plus y divided by x minus y and x square minus y square divided by x square y square. Friends, we know that let a be the mean proportion of these two, that is x plus y divided by x minus y and x square minus y square divided by x square y square. Now we have that a square is equal to x plus y divided by x minus y into x square minus y square divided by x square y square, which will be here the x square minus y square could be written as, by using the formula, a square minus b square is equal to a plus b and a minus b. We will use here x plus y divided by x minus y into x plus y in one bracket, x minus y in another bracket divided by x square y square. Here x minus y and x minus y get cancelled, so we will be getting x plus y bracket is to square, two brackets we are getting here, divided by this x square y square. Now taking square root on both sides, a is equal to x plus y divided by x y. Therefore, mean proportion of this x plus y divided by x minus y and that of x square minus y square divided by x square y square is x plus y divided by xy. Friends, what we have been discussed today in this session is continued proportion, K method, then problems from the practice set 4.5. Friend, will you try these problems? That is, if x is the geometric mean of 25 and 4, then find the value of x. If 4 a square b, 8 ab square and p are continued proportion, find the value of p. Which number should be subtracted from 7, 12 and 18 such that the resultant number are in continued proportion? Fourth one, If A, B, C are in continuous proportion, then show that A plus B bracket to square upon AB is equal to B plus C bracket to square upon BC. If A, B, C are in continuous proportion, then show that A upon C is equal to A square plus AB plus B square divided by B square plus BC plus C square. And the last one, 5 numbers are in continuous proportion. The first term is 5 and the last term is 80. Find these numbers. So friends, try these problems. You should not forget the famous words. Math is an essential part of the student's life. It lays the foundations for complex thinking abilities. During their school years, they must learn basic math along the way, even if they decide to pursue other subjects in the future. So, with these words, I would like to say thank you. We'll meet in the next video. Till that, bye.